Okay, so in this video we are going to talk about a new concept in our critical path analysis, which is forward and backward scanning. Now, both of these strategies, which we're going to call them these techniques we apply to our network diagrams, help to tell us two important things about each activity in our network diagram. Now, one thing is the earliest start time. So this means the earliest time that any activity can be started after all prior activities have been completed. Now, this will always be 0 if there are no prior activities, otherwise it is greater than 0. This part here kind of makes sense, right? Because if there are no prior activities, it's the first thing to do basically. So the earliest start time is 0, say 0 minutes at the start of our project. Now, our second part of this, which backward scanning is going to help us with, is this idea of the latest start time. So the latest time that an activity can be started before delaying the entire project after all prior activities have been completed. Now, it's just a simple way for us to visualize this, because when you look at this in a textbook, it goes straight into these network diagrams and there's all these new things that come up, so it can look quite overwhelming. So let's take like a simple example basically for each of these two concepts. Now, we're talking about earliest start time, so the earliest time an activity can be begun after all the previous things are done. So let's take a really easy example of making a jam sandwich, right? So let's say our first activity is we are going to put it in the toaster. So we put this bread in our toaster, and let's say this is activity A. This takes 2 minutes to toast. Okay, our bread takes 2 minutes to toast. After that, let's say you really like butter on these sandwiches. So the second thing you're going to do is you're going to put some butter on your toast. But think about it. You can't butter your toast until this activity has been completed. You can't do it until basically you have your toast ready. So that means that here, I should say also for my toaster, because it's the first activity, the earliest start time will be 0. The earliest start time for putting butter on my toast is going to be, let's say the time is in minutes, is going to be 2 minutes, okay? Because we can't do it until the 2 minutes have passed that our bread has been toasting. Now let's call this activity B. Now let's say putting butter on our toast takes 1 minute. And after that, we are going to put some jam on our bread. Okay? Now, the earliest we can put the jam on, if we, for example, as this goes along toaster butter jam, say we like to put butter on first, the earliest start time for us putting jam on our bread is 3 minutes, because we have to have completed each of the previous tasks. We have 2 minutes in the toaster and we have 1 minute putting butter on. So the earliest start time for this activity is going to be 3. And let's say this takes another minute, okay? We're not even using network diagrams here. We're just looking at trying to understand conceptually what we mean by the earliest start time. I hope that kind of makes a bit of sense. Now let's look at our latest start time. Let's take an example. Now imagine that you are on a building site, say a construction site, and you are let's say a painter, okay? Now you're here, you are a painter, that's you. You have to paint this house, and basically after you, there is a plumber coming to do an activity after you. Probably should have these the other way around. Hey, I feel like plumbing would happen before painting. So let's say you're a plumber, and there's a painter who has to come in afterwards. Now, if as the painter comes, they require the plumbing to be done, but let's say they are coming at maybe 1 p.m. And as the plumber, you basically, let's say the earliest start time is whatever the project entails, but let's say that as a plumber, the plumbing job takes 3 hours. We don't want to keep the painter waiting because that's going to delay the entire project, right? This is what we've talked about over here. So as a plumber, your latest start time is going to be these 3 hours before 1 p.m. So here, we're going to go 3 hours back. That is going to be 10 a.m. So before we can start the plumbing whenever we want. The earliest start time may have been something earlier, but the latest we can start this task is at 10 a.m. Because this is going to take 3 hours, we don't want to delay the painter. If we start this at, for example, 12 p.m., the painter's here at 1, but he's wasting basically 2 hours waiting for us to be done at 3. So we can kind of see here that if we mess up the timing of this, then it can significantly delay a project. A plumber coming in and starting later than the latest start time can be pretty disastrous, especially if you're looking at a large scale kind of operation. And this is what our network diagrams are all about. We're really just talking about activities and that make up a project. Now, going into example 1, we have this network diagram here, and you can see that we suddenly have all of these boxes that have appeared, okay? Now, this is where I was saying it starts to get a little bit overwhelming, but we're just going to break it down bit by bit. Now, our forward scanning is going to help us to determine the earliest start time. I'll actually write this over here. So our forward scanning helps us find the earliest start time. Our backward scanning gives us the latest start time. Now, forward scanning means we are going in the forward direction. So we're going from start to finish. So we're going to scan forward from left to right. Now, in each of these boxes, typically on our network diagram, these boxes tell us for our activity the earliest start time, which goes in the left, and our latest start time, which goes on the right box. We're basically going to follow along and fill out these boxes as we forward and backward scan. Now, activity A and B have no prior activities to them, right? They are the starting point. And as we said before in the sort of key idea at the top, the earliest start time for our first activities is always going to be 0, right? It's the beginning of the project. Now, we have written these boxes, as you can see, above or below all of the vertices of my network diagram. So all of these points that I've drawn in orange. Now, after activity A has been done, this box over here, let's highlight it, tells me the earliest start time that activity C can have. So 1 hour, for example, 1 hour, 1 minute, 1 unit of time has passed after doing activity A. So the earliest I can start C is at 1 hour. Now, for our activity D, we can see that whether we go along B, which takes, for example, 2 hours, or A 1 hour and C another hour, both of these different routes along our network diagram equate to 2 hours passing. I'm just using hours. You can think of this as minutes, seconds, whatever. The earliest time I can start activity D is going to be 2. Okay? After doing activity D, so once we go along here, we've done activity D, it takes 1 hour. The earliest I can start activity E is going to be 1 hour after that. So 3 over here. And then finally, activity E takes 2 hours, so I will finish at 5 hours. That means this entire project is going to take 5 hours to complete. This is our forward scanning. It tells us what the earliest start time for each activity is. And we measure the start of this activity as the vertex. For example, I'm looking at the activity C here. The vertex before that edge on our network diagram. Okay? So we've done our forward scanning. This is the earliest start time of each activity. We are going to backward scan now. So we're going to go in the opposite direction to find the latest start time of each activity. Now, always at the end, at the start and finish here, but particularly the finish, these two will always be the same because now we have to work backwards. So every time we get to the finish, we expect these numbers to be the same at the finish. I'm actually going to write that down here. Always the same. And now we basically want to move in the backwards direction to find the latest start time of each activity. Now, because we're adding in the forward direction, we're going to assume that we are going to minus in the backwards direction. So here, I'm going to take away 2 from 5. My latest start time for activity E is 3 hours. I'm going to continue going backwards, so I'm going to minus this one here, because 3 minus the 1 from D gives you 2. Going up to the top here, D, activity D, minus the 1 here, 2 minus 1 gives us 1. So the latest start time is going to be 1 hour for activity C. And then subtracting the 2 hours from B, subtracting 2 from this number over here is going to give us 0. And same as up here, 1 minus 1 gives us 0. Now this looks really neat, and you could be looking at this and going, well, that's easy, the numbers are always the same. This isn't always going to be the case. This is a really neat example for forward and backward scanning where the latest start time and earliest start time of each activity is the same. But this is not always the case, as we'll see in a harder example, which we're going to do next. Now, as you can see, we already have a trickier network diagram. We still have these boxes, but we have a lot more going on. And now you'll start to see how this is going to play out and how these different times may affect our network diagram and the earliest start times and latest start times for each activity. Now, once again, we're beginning over here, and you can see this first vertex, my starting vertex, has 4 activities coming out from it. Activity A, B, C, and D. So, remember, these are the first activities. They have no predecessor. So, their earliest start time is always going to be 0. Now, we are going to forward scan first to fill in all these boxes on the left. I'm going to start at activity A. Now, activity A takes me 11 hours. So that means the earliest start time for my next activity, E, is going to be 11 hours. I cannot start this until the predecessor, A, is complete. So that is going to be 11 here. Now, some of you, when you're looking at this, you may want to go straight all the way across, so you go like bang, 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 and I'm done, right? But we want to kind of work from left to right systematically, because there are certain issues that arise sometimes when different activities lead to the same vertex. They're going to affect our earliest start time. Now I'm going to go down to activity D. So 4 hours have passed here. So I can just put down 4 here. And then I'm looking at activity B. So this one over here, 2 hours pass. So the earliest start time for my next activity, which is activity F, is going to be 2. And here is where some of those issues we talked about arise, okay? Because as you can see here, I have 2 possible numbers that I can get in here, right? I can either get, if I follow this place, 11 plus 7 gives you 18. So that's one option. Or I can go 2, and 2, which gives me 4. So how do we know which one to basically pick? Well, when we forward scan, we are always going to pick the larger number. Now, the reason why is that, sure, B and F get done really quickly, but we can't do our next activity, which is activity H, until everything before every prior activity has been done. So in order to commence H, I really need this, 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 and this to be done. Now, B and F get done quickly. They only take, for example, 4 hours if we're using hours again. But A and E, they take longer. And we can't start H until everything is done. So we have to think about this longer path over here from A and E. So when we forward scan, we always pick the larger value because everything needs to be done before we commence our next activity. I hope that makes sense so far. But these, like with all things, are going to take practice, and they're kind of weird to get used to. This is very new. We haven't really done anything like this in maths beforehand. So if you're struggling, it's all good. Now, we're going to go after my activity of G. This takes 7 hours. So the number in here is going to be 4 plus 7 gives you 11. And we get this thing happening again where I need to get to this vertex before J. So I can either go from here or from here. And as we said before, remember, in order for J to happen, H and I and also C need to have happened beforehand. We can clearly see here C only takes 4 hours, so that's fine. That's not really making too many issues for us. But we have to look at the longer time here. So I'm going to take this path here, 18 plus 5, that gives me 23. Because remember, everything needs to get done before I can start activity J. So my earliest start time for activity J is 23 here. And then after that, for the finish, J, 23 plus 12 gives me 35. So that gives us 35 total hours, for example, to complete this project. Now you're probably looking at this and going, well, are we just going to ignore these examples where I had less time? No, because this is going to have an impact when we backwards scan and go in the negative direction. This is going to tell us the latest start time of each of these activities. So we're going to start to backward scan here now. Remember, at the finish line, these two are always going to be the same. And I'm going to backtrack, so there's only one edge going from the finish backwards. That's 12, so we're going to subtract 12 from 35. Gives us 23, same kind of thing. And now you will see the effect of these different paths. If I go down here, I only takes 2 hours to do. So I'm going to subtract 2 from 23, and that is going to give me 21. Now, what this means is for activity I, the earliest I can possibly start it is 11. But since all these other activities are happening, I have a little bit of time before I do I. So the latest possible time I can start it is at 21 hours through this project. This is the effect of our earliest and latest start times. Now, if we continue to kind of scan backwards, this one's going to be 18 because 23 minus 5 gives you 18. And we're just going to fill in the rest of this. Now, from this vertex where we have 18, 18, if we go back along this edge of activity F, this only takes 2 hours. So the latest start time for activity F, I can do 18 minus 2, which gives me 16. So once again, F, the earliest we can start it is 2 hours, but the latest we can start it is 16 hours. So we may want to start it really, really close to 16 so that it gets done around the same time that these ones get finished as well. When you look at this applied in like a project, the way we order tasks and the timing of it can be the difference between a successful and an unsuccessful project. So it's important to get all of these numbers correct and to know what they actually mean. Now, going back again along here, activity E takes 7 hours to do, so I'm going to subtract 7 from 18, that gives you 11, and I'll look down here now, my 21 here minus my 7, I'm going to get the right pen here, I'm going to get 14. So that means my activity G has an earliest start time of 4, a latest start time of 14. And now we've basically filled out everything except for these 4 starting edges. And this is where we're going to take all of our final values and subtract them from the actual edge. So here for A, my latest start time for A is going to be 0. So what that tells us is along this path of A and onwards, this thing takes the longest time. So it's really important for activity A to start right at the start of the project. Now, if we go backwards from here, 16, we subtract the 2 from activity B. This gives me 14. So this means the latest time I can start activity B is 14 hours after. So if you're a project manager looking at which activity do you want to do first between A and B, this guy here can probably wait because we have 14 hours that we have to play around with before we start it, okay? A is the more pressing option, okay? Now, going backwards here as well, from this vertex back to here, our activity C just takes 4 hours to complete. So my latest start time for activity C is going to be 23 minus 4, which is 19. And from here, activity D, I'm subtracting 4 from 14, which gives me 10. So as we cycle through, as we go through forward and backward on our network diagram, doing these scanning methods can tell us for each activity how early we can possibly start it and how late we can possibly start it. And when you start looking at on a larger scale with these projects that we talked about, say a construction job or even cooking, the timing is really important. So the forward and backward scanning and the idea of earliest and latest start times can give us a really good idea about how we want to prioritize the tasks that we do. And once we get used to this system, we can really quickly fill these out through this method of scanning forward, which is this direction, or scanning backwards in this direction. This brings us to the end of the video. Thank you so much for watching, and I'll see you next time.